Okay, and I am now recording, so let's begin today's stream. We're starting a bit late because my internet cut out for like half an hour right when I was about to start streaming, so I think I'm just going to skip introductions and go right into what I'm working on, which is I'm revamping my scheduler. So let's get right into it. Right off the bat, I've got a compile error. Cannot borrow dependencies as mutable because the first mutable borrow occurs here, because I push new work which is borrowed. I wonder what happens if I do ref new work, will that ooh. So that did solve it. Yeah, so I know I'm not using finish currently. I know that's going to be a bug in my program. Oh boy. Lots of warnings. Unstable library, Finbox. Alright. Gunship.rs. So we got shebang, feature, Finbox. Finbox. So where are we now? Hooray, just warnings. Unimplemented, gotcha. Unnecessary unsafe block. Also good. I've been trying to, part of this rewrite was also cutting out a bunch of unsafe code, because I've suddenly become much more allergic to unsafe code. Ah, here we go. So this, I would like to clean that up. I'd like to get as little unsafe code within the engine core as possible. Next work never used. That's also a bug. That should be used at some point. Fortunately, we're not using unique anymore. Sync sender. Am I not using that? I guess. So what happens when we create a work unit? What happens inside start? So we get our function. What we do is sender receiver result equals func sender.try. Oh, so we never name that by type. So we don't need to import this. We don't need arc. We don't need from iterator. Init thread. Current is no longer needed. We just need to call init. Run weight fiber. Same dealio here. All we need to do is initialize it. We don't care about the value. Work func is never used, which seems not right. What do I have going on here? what happens inside start when I collapse these? Work proc. Oh. Oh. Okay, I'm gonna leave those both as warnings for right now. But I'm thinking that I've got a lot of bugs. I'm pretty sure these should both be used. At least that function should be called. Finish is not used, we knew that. Method never used. Awesome. What was this one? Inside engine. Right, we haven't. This is like, this right here is what I'm trying to get to, but I haven't. I've got to like rework my scheduler for that to happen. So let's go to cd gunship, and then let's set rust flags, not set, set rust flags equal dash error format equals JSON. And let's see what happens if I do cargo run example experiment. Will it recompile everything? It will not. Excellent. Oh, shit. I gotta do this. Build example. Beautiful. Beautiful. Async. Alright, oopsie. Build example. So standard marker sized is not satisfied. String does not have a constant size known at compile time. Right. So what we need to do is, this is definitely just like a typo on my part. P does not need to be sized. Because does that go the other way? Size question mark? Let's check the internet. I totally just recently had a thing open that used that syntax. What was it? RefCell, probably? I think RefCell implements everything for optionally sized stuff. Or I am going crazy. No, here we go. Where T is question mark sized, which I swear is exactly what I just did. Are you messing with me? Are you just being a big old stinky jerk? Okay, so that compiled now. So let's do build example. All right, so I got a good question for the folks at home. Why did I have problems with load mesh but not load material? Those functions should have almost exactly the same signature. Let's take a look at what load material is doing. What? 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 Oh. 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 Okay, so this is here's an interesting one. So I was getting a compile error on that. Ref static, or P is a lifetime static. Well, let's compile now. Oh, I do have to match the lifetime. So specifically what I was getting here is if we go back a little bit, I believe it was like, oopsie. If we do let path equal path.asRef, see what the error is I get on this. Yeah, so we get the error that P is not marked. So that's not the right one either. Yeah, here we go. We get the error that P might not live long enough. Except I do believe that I also had it marked as static. Yeah, so it wasn't that P wouldn't live long enough, it was that the variable path might not live long enough. The type might be long lived enough, but the particular object that gets passed in might be a reference that only lives, you know, to the lifetime of the function. And then, but this is used later. This is turned into a function that doesn't get invoked until, you know, sometime down the road. But we do the same thing over here. Oops, too far. We do the same thing over here. Same signature. P is static lifetime, as ref path and send, and it works in here. The question is, why? Is one of these an error, and if so, which one? And the answer is that this one should probably be a compile error too, because I am definitely using path, and if the lifetime of path, if path doesn't live long enough, then stuff is busted. But this is a move. Oh, you know what? This is a move closure, so path gets moved into it. And so why does that not work here? Why is it not that, you know, bar value only lives till here. It only lives the entire life of the program. Borrowed value must be valid for the static lifetime. That's weird. But we don't need that. We just need send. Yeah, so path should have been moved into this closure because this is a move closure. So why is this giving me lifetime complaints? Path does not live long enough. Borrowed value only lives until the entire lifetime of the closure. Borrowed value must be valid for the static lifetime. Oh, you know what? It's probably because load file text probably requires a static. Which makes sense. So let's take a look at path.extension and see what we can do with this. Rest path. I'm guessing path.extension borrows the type. Yes. Okay, so this is a bit troubling. So let's do this. So now we should just have some more mundane. Oh, into owned. It's very nice if we could just convert it to a string. Into owned. Cow into owned. Borrow to owned. Well, I think just into string would be enough. Into string. Right, and then I can just do path.into. Path.int. Yeah, this is cannot move out path. Yeah, this is that whole non-lexical lifetimes issue that we hope one day Mir will solve, but it is not currently solved. So we know that, so we borrow the extension from the path using this this extension method. At the very least, we know that, oh, you know what? No. So we know that we borrow that extension, which is just like a string slice, and we borrow it for as long as it takes to do this check, but we don't some ext equals a, but we never use this value again outside of doing this check. So inside here, it should be safe to move out of path. Like, we know as the authors of the code that it's safe to move out of path here because we never try to use ext. So if ext gets invalidated, it doesn't matter. There's still not going to be a use after free. And in theory, the compiler should be able to tell that, but currently it can't. And so that will be implemented eventually. But right now, the compiler thinks, you know, ext is in scope, we're still borrowing path, so we can't try to destroy path, which is effectively what this is doing as far as the compiler is concerned. So the one option is to temporarily do an allocation here, like allocate a copy of path or allocate a copy of extension, just specifically for the purposes of doing this. Another option would be, the other option is we actually change the signature. So we do like make this take a ref static. P itself no longer has to outlive static, but P does have to be sync. Where did that leave us? Oh, we have to go back. Hold on. Gotta undo that, take it back to what it was before. Actually, leaving an into string on there would be nice. Well, let's go back for a little bit. So where were we? I want to go back to the one where where P was optionally sized. Right, was this compiling? Where do we have this compiling? There we go. Let's check out this build example. All right. So yeah, so this is the other option, is we change the signature to be able to take just, an arbitrary, or to take a static reference to a P. The downside to this, so like this works for now because I know I'm only ever passing in like a string literal, so that'll always be, that static lifetime, that's always fine. However, this is less flexible because it can only take a ref static, whereas before it could take any P that was able to be converted into a path, a ref path. So, if I were to dynamically concatenate a bunch of strings together to get my path and then pass that into load mesh, that no longer works. And that's not what we want, because we know that load mesh is going to take ownership over that string object, so it's going to be safe. It really is just like what we want is this one. Oopsie. No, not that one. This one. Right? No, not this one. Go back a little bit further. This one, I think. Yeah. What we want is this one. Nope. Go back a little bit further. That one. Yeah. We want where we can take any P, whether it is a reference type or an owned object like a string, as long as we want to be able to take any P as long as it meets these requirements. We need to be able to convert it into a string for error handling purposes. It needs to be able to be sent to other threads because that's what our multi-threaded system is all about. It does have to survive the static. It doesn't have to survive. It's got to outlive the static lifetime, might be the way of saying that. And we have to be able to convert it to a reference to a path. The only reason why this is currently failing is because of annoying nastiness. So here's what I'm going to do. Whoopsie. Let extension equal blip dot map next into. Then we're going to do match extension, and so what that should do option string is oh, god damn it, you're killing me here. So what did I have to do to convert an OS string into a oh damn it, I don't still have it here. Basically what I'm going to do is I'm just going to make a copy of the extension and then slap a to-do on there that says, hey, once we get non-lexical lifetimes, let's fix this little bit of inefficiency. OS string. Yeah, the process of going from a reference to an OS string and all the way up to a string is a little bit convoluted. We actually have a ref OS stir. So there's a ref OS stir, and we want to do toString lossy is, ooh, cow has a lifetime. So let's do to stir let's do toString lossy, and then can I do into owned dot toString lossy dot into owned. Will that do the trick? Some ref. Will we compile? Yeah, okay, so that's compiling now. Build example. Alright, so all my janky junk is compiling once again. And I should expect it to completely fail when it runs, and, you know, what do you know, it does. And it did not, I know the, oops, that's not what I want. And it panicked instead of segfaulting, which is exactly what I want. I would much rather have a panic than a segfault. So let's see what failed here. Scheduler, wait for work. Atomic init cell, mutex. Let's see, wait for work 17. No, that's not it. Wait for work, scheduler 149. Mutex instance borrow. So borrow should only be doing a shared borrow, so libcore option 707, that is oh, you know what, I bet this is option.expect. That's why it's showing up as having come from libcore option. Alright, so let's check out the atomic ref cell code, because it looks wrong to me. So now we dig into my cell extras crate, which is where all my little extra extension cell types live. Let's take a look at atomic ref cell. And phone spooked me. This is atomic ref cell, but we want atomic init cell. Atomic init cell just has borrow, which does self.0.borrow. Atomic init cell is just a wrapper around atomic ref cell, which simplifies the, like, does a simplified API. Changes the semantics a bit. So we do self.borrow, maybe .asref. Already muted with borrow. So already muted with borrow. Who is? You know what? I bet it totally is just my engine code. I bet it totally just is my engine code. So let's take a look here. Inside scheduler, who's doing borrow mute? Because we should basically be never doing borrow mute. Wait fiber. It's going to be instance.borrow mute. Scheduler 149 is instance.borrow. Let's do instance.init instance.borrow. Oh, What's our call stack? Because you know what could be happening? Init could be happening before it is, or init could be happening after it gets borrowed. I don't think so though. The atomic init, if that is what's happening, and this is the error I'm getting, that's a bug in atomic init cell, because atomic init cell should be giving a different error than that. It should be giving an error like cannot borrow an uninitialized such and such. So let's walk up our call stack. So 149 is called by run wait fiber 120. 120. We should call wait for work, which calls fiber init, which is indeed. So probably what's happening is run wait fiber. If we take a look at engine and we take a look at our initialization code, we spawn a thread, we do run wait fiber, and that all happens before. So now when we call wait for work and wait for work tries to use the scheduler, that happens before the scheduler ever gets initialized. So, you know, yay me for forgetting to do things. Scheduler with make sure the scheduler is initialized before first use. This kind of weird initialization pattern is not something I want. Oopsie, scheduler : but that's something I can address later. What are you doing to me? Does this have to be a move? Why would it not be a function once? Oh, Dedoy. Yeah, we have to specify that this closure takes a type parameter. Alright, so let's give this another try. And so this is why I am moving, so I'm like trying so hard to move against unsafe code, because a couple of weeks ago that crash that I just ran into would have just been like attempting to use uninitialized memory. It would have been a seg fault that would have taken me 2 days to debug. And it's just like, it was something that worked fine before. I refactored things and broke it. An easy mistake that anybody could have made. And in C++, it would have been a nightmare to figure out. So, yay, Rust. Ooh, but now we've got an actual seg fault. I mean, I knew things were going to be wrong. I did not think it would be a seg fault. I thought the program would just deadlock. Well, against my better discretion, let's pop open a debugger and see what happens. Visual Studio 2015. Alright, let's see what's going on. This is gonna take forever. Yeah, it's gonna take forever. Alright, what's our call stack looking like? Func fiber. Fiber. Access violation, reading at location C. Seems like it could be incorrect. Our fiber platform is wrong. You know what? I have test code, so I have a little bit of test code. cd lib fiber cargo run test or cargo test. So I've got a tiny bit of unit tests. Oh, well. So running 0 tests. I don't know what the difference between these two is, but one test, but error, test failed. Yep, that seems about right. So let's do lib fiber source lib. Alright, so we want, in this case, fibers library and we want the fibers library and the Windows platform specific one. I think is probably where most of our nightmares are happening. Oh, well, that's where my nightmares are happening. So I refactored this a bit. Basically, I get ownership over a closure, and then I box it up to get a trade object, and then I box it up again in order to get a pointer to that trade object that I can then send to here, data LP void. Data LP void gets converted to a star mute box fn once. Box fn once or box fn box? Box fn, not even fn once. Box fn. Right. Oh, actually, that conversion to a trade object might have still worked, but let's not transmute this. Func, right? Let's compile. Oops, it's not that, it's a box fiber, right? This takes fiber as a parameter. All right, so let's try that test again, see if we still crash. We totally do. Well, let's start debugging this the old-fashioned way. Line fiber proc. Invoking callback. Invoking user provided fiber proc. All right. So let's see if we even wind up around there. You know what? I don't think we get a standard out from tests. So we'll have to set up an example. Yay, my favorite. Alright, so let's go fiber, new folder, examples, new file. Sample.rs. You know me, I'm super creative. Main extern create fiber, use fiber, get that fiber. Build example. Cool. Cargo run example. So in fiberproc, invoking user provided fiberproc. No huge surprises there. So let's dig in a bit deeper. So let's see. Inline. Func pointer is func pointer. Data. Oh wait, func pointer. Some fiberproc. All right. So func pointer is as LP void. Let's give this a shot. All right. Those function pointers look about the same to me. So the next thing to do would be see what the actual trait object is. So let's see. This will probably be more easily achieved in the debugger, I'm thinking. So let's stick a couple of breakpoints in here, like one right there and one right there. And then let's, I don't know, just run it and see what happens. I'm gonna have to be cutting this off in a couple minutes. All right. I think I'm running the wrong thing. That's fine, I can, oh, that's totally not gonna be right at all. Alright, let's kill this and try again. Alright, let's debug it. Let's give it like 10 minutes to open up the file. Gunship lib fiber platform windows. I would not want you changing my line endings. Are my line endings inconsistent? I'll be very sad if they are. Okay, so we want a breakpoint right around here and a breakpoint right around here so that I can examine both of these trait objects that we get. Let's restart. And let's just try running it. All right, there we go. So what is func pointer? Func pointer points to this smelly jerk. It's memory one. Func pointer. And we're looking at 4-byte integers, I do believe. Zero, 0, 1. And oh, I think that's Rust's version of a null pointer. So captures no data, perhaps? Is that right, based on the example we're running? That is not right. This, oh, you know what? It totally does not capture any data. So that's right. The environment is null, and then the this jerky jerk is if we stick this in watch one, we should be able to do void star that. Is this not a valid memory address? This should be the memory address for like this function right here. That is I have no idea where that code is. So let's see. So what's boxed func? Let's see. Where does boxed func? Boxed func live? It's ref boxed func. We are on a. Are we running this in 4 bytes or 64-bit? Ah, fuck. I don't know if this executable is a 4-bit or 64-bit. I'm pretty sure I'm compiling on a 4-bit or 64-bit. I'm pretty sure I'm compiling this on a 32-bit compiler. Maybe what I should do is at the top here print out size of usize. std mem size of usize 4. So it is a 32-bit system, which means when we do this junk, we should be looking at 4-byte integers, hexadecimal display, and then we should go to we can kill that. We should go to func pointer. So func pointer should point to that. Void star. Well, that's not goddamn helpful, is it? Well, either way. So we think that our pointer is this boxed func, huh? Boxed func is a closure star star. Ref boxed func is a closure star star. Boxed func is a closure star. So let's go forward now and see what this is. So let's take a look at data. Data is a pointer. Closure data is a closure star star. If we expand it, we'll see that what it points to makes no sense. So what I'm thinking I'm doing wrong is my logic in here with boxing boxes and boxing closures, I think I might be misunderstanding something about either trait objects or what happens when you box a box. Either way, I gotta cut the stream off for now. But I'll probably solve this issue offline, and then hopefully next time I come on to stream, we'll actually be back up in the engine, and hopefully I'll be able to quickly deal with the last few issues with the scheduler, and I'll be able to get back to the more interesting stuff, which is actually starting to write some sample gameplay code and get the engine working for that. So I'm excited for that. Thanks for watching. Come back soon. I've got links if you're interested in watching future streams. I put links to my Twitter account on both Twitch and on YouTube where I upload the videos. My Twitter account is where I announce streams, although I announce them like 15 minutes in advance, so it's kind of, if you see them, come watch them. Either way. So thanks for watching, and I will see you all next time.